Hello everyone, welcome back with another tutorial of MATLAB, and today we'll look into the different data types that we can have. Before going into the details, let me quickly show you how you can define variables. So MATLAB is you can use it similarly like as you use calculator. So you can define variables that x is equal to 2, and then you want to define another variable x5 is equal to 3, and you want to sum them x plus y, and you will get the result. So let's see, you can see z is equal to 5. You can also see in workspace, you can also see in command window. Sometimes you don't want to see output in the command window and you just want to see the results in workspace, so you can suppress this output like adding semicolons at the end, and that will suppress your output. Let me clear this, run it again. So this time you can only see the commands here in the command window, and you can see the output in the workspace. Another suggestion before starting my today's video is that every time you write a program, write these 3 lines of code: close all, clear all, and CLC. Clear all means that it will clear everything in the workspace. Let's run this, boom, and you can see there is nothing in the workspace. Close all is basically when you close all, that means any other windows that are open, like for example you have plotted something and there are some figures over there, you can close all and it will close everything there. Currently we don't have any windows, so that's okay. And then if you want to remove everything from the command window, you can use the CLC, and that will wipe away everything that is appearing in your command window. Okay, now let's get into the different numeric data types that are there in MATLAB. The first one and the default one, let's say you want to define any variable, and that would be defined as a double variable if you do not specify it. Let's say I want to define okay, before defining, let me tell you other variables and then we'll define and then we'll look into it. There are other variables which are single type. In double type you can store variable as 64-bit or 8-byte, while in terms of single variable which are like less precision, you can store it as 4-byte or 32-bit. However, you can also define some variables as integers. Integers can be signed or unsigned. You can see signed here and you can see unsigned here. Signed means that the integers are negative as well. However, in unsigned, the integers are always 0 or positive integers, which are always like non-negative. So in terms of storage, you can define it as 8-bit, 16-bit, 32-bit, and 64-bit for signed, and you can similarly define 8-bit, 16-bit, 32-bit, and 64-bit for unsigned. And there are different ranges, like for example 8-bit unsigned integer will store from -2 raised to power 7 to 2 raised to power 7 minus 1. Okay, so this is the range. Similarly, I have written all the ranges here, so if you are interested in what are the different ranges in which 16-bit variable can be stored, so these are the minimum, this is the minimum, and this is the maximum. Similarly, this is the minimum and this is the maximum integer in 32-bit that can be stored as signed integer. Similarly, there are ranges for unsigned integers as well, and those start from 0 and goes up to the right hand side. You can see here 2 raised to power 8 minus 1 is for example for 8-bit signed integer. Okay, now let's get into some details of these different numeric data types. So first of all is the double one. So whenever you define a variable, it is automatically defined as a double integer, double variable. Let's say you define x is equal to 8, and you can see this is double here. This is the basically class appearing in workspace. You can, when you right click here in workspace, so you can go to choose column and you can see I have checked class already. If I remove it, you will not see this class. So if in your window you can't see this class, you can just simply right click here, choose columns and select class, and you will see the class. Now whose x is another command which will give you the attributes of this x variable that I defined. So if I run this command, you can see name, size, and then class and everything. So you can see it's double here. let's say you have a variable that is of a different type. For example, I am defining this variable y is equal to false, which is a logical variable. So false means 0 or true means 1. So I have defined it false as a logical variable. You can check class, by the way, with this another command as well, like class of y. Y is the variable that I define. So if I run this command, I'll see the class of the command, which is logical. You want to convert this logical variable into double variable. So what you will do is you will define this command, you will define this y as double of y. So y is already defined, which is logical, but now you want to convert it to the double variable. So when you will run this piece of line, you will see this y double, or this variable which was initially logical is now defined as a double variable. Similarly, you can check the minimum and maximum values of this. As I told you, here you can see the minimum and maximum values of the integers, but now you can see minimum and maximum values of this 64-bit 8-byte double numbers. So let's see. So this is the minimum and this is the maximum number this is the maximum and this is the minimum double integer double data type variable that can be defined in MATLAB. Similarly, for the single data type, again you have to define it, because if you don't define it, it would take it as a double variable. So let's say you want to define 8 as a single variable, you will define it single of 8, okay, single, and within the parentheses you will define that variable that you want to define. For example, 8 you want to define. So let's run these two lines and see what is the outcome. You can see this is a single variable and you have successfully defined a variable 8 as a single variable. Now same is applied to single variables as it is applied to double variable. Let's say you have a variable which is in double form and you want to convert it to single. You will use same commands. You can pause the video, go back and forth and see the difference in the commands, and these are super close to each other, similar commands. Only thing is, initially now you have defined a double variable and now you want to convert this double variable to a single variable. So these are two lines. I run it and you'll see this variable is double, and now you want to convert this double to single variable. So you will run these two lines and you will see it is defined now as a single variable. Similarly, you can see the maximum and minimum values for the single variable as well. Just run it here and you can see maximum and minimum values. Now with int 8, which is the signed integer stored at 8-bit, you can define it. Again, the syntax is similar. You will define class first and then within the parentheses you will define that variable. When you'll run it, you will get the output in the form of int 8 variable. You can see it class here, and if the variable is of other type, let's say this is double variable, and you can now redefine it in the form of int 8 variable as well. So these are all similar commands, but different classes here. You can pause the video and you can see these commands, write down on your own and practice so that you can remember those commands. I'll not run each of these commands to avoid redundancy in this video. So for 32-bit, similarly 64-bit, only name is changing, everything is same. Now in terms of unsigned, now another thing that you will change is, instead of int 64 or int 8 that you were using in past like this, you are using uint 8. okay, this is the command. Now it will define the variable as unsigned integers. Okay, similar for 8-bit, 16-bit, 32-bit and 64-bit. Now I already told you how you can convert variable from one type to another, but there are two other syntax that you can use to convert one variable class into the another one, which is cast function. So the first one is cast a and new class. A is the variable that you want to convert the data type, and new class is the class in which you want to convert. Let's say you define this variable n, and let's see, this n is int 8, signed int 8 variable. Now if you want to convert it to the unsigned int 8 variable, you can define its class in the parentheses and within these inverted commas, and then you can define this variable which you want to convert, and then you can run this line and you will see the output, and this is unsigned int 8 which you want. Similarly, there is another syntax which is cast a like p, in which you want to make a looks like p. So let's say you define variable x which is of certain class, let's say 30 int 32, and you run it, you can see it's int 32, and now you have another variable which is of this form which is double, and now you want to convert this x same as what the format you had in y. So you will use z is equal to cast x like y, and it will convert x to the double form as y was in the double form already. See, this is z and z is double now. Okay, let me clear the screen and then we'll move further. Now with that, you have seen different classes and you have seen how we can convert between those classes back and forth. Now the third thing that we'll cover today is query type and value. Let's say you want to see if certain variable is an integer or not, if certain variable is a floating variable or not. You can use several query types that are very important, and you can use them in the conditional statements later on when you write the program. So these will become handy, so understanding them at the start would be beneficial. Let's say you want to see if a certain variable is an integer or not. Let's say 2 is an integer or not. You will run this command is integer, and within bracket you will write that variable, and once you run this you will see 0, logical 0, that means wrong. So it's not an integer because I told you guys at very start that when you define a variable without specifying the class, it's a class double, it's a data type double. Whenever it is a data type double, that means it's not an integer. If you want to define integer, you have to explicitly define a class. Let's say you want to define 2 now as an integer of int 8 type. So now you can run this command and you can see this is logical 1, that is true, that means this is an integer now, that's correct. Now you define another variable and see if it is an integer or not. So no, because you haven't defined, you haven't specified it as an integer, so it's not an integer. Similarly, if a certain variable is a floating variable or not, you can define it by you can check it by using command is float. Now pi that I use in this example, MATLAB is smart, it knows what is pi. So let's say pi is 3.141, which is of variable double. Okay, let me see, x is equal to pi. So see, x is equal to pi is a type double variable. Okay, now double variables are floating variables, so if this is pi, this pi is floating variable, then the condition should be true. Okay, let's run this. So see, logical 1 is, that means the condition is true. Now logical 1 is a logical variable which is not a floating variable. Let's check if this logical 1 is floating or not. So is float pi is logical 1. Now let's check this is true or not. It should be false. So you can see it's false. Similarly, if you want to check certain number, is it a numeric or not, already defined this number a, which is double type, so that is numeric. Double are basically the type, data type, and that comes under the hood of numeric. So let's check this and you will see it should be true, it's correct. Similarly, if you want to see if 2 is numeric data type or not, yes it is. And now I have defined this string ABC that shouldn't be a numeric, and we can check it, the condition is false. Similarly, if you define a string of let's say complex variables and then see if that is real or not, I mean if you want to check a certain variable that is real or not, you can check it. And for now I have defined this a, let's say, and it is complex. You can see a is complex, and now if I check if it is real or not, it should be no. You can see it's wrong. Similarly, if I define a as 8, if it is real or not, we can check it, and it is real, right? Similarly, is finite. We can check whether a certain vector is finite or not. So let's run this one first, and you can see this is infinity here, the third element. Okay, and let's check it. You can see this is false. So that means third element is not finite while the rest are finite, and that's why the rest is correct. This one, where the next one is whether element is infinite or not. Now this is basically the complement of the previous one. So let's run these two pair of lines, and you can see now only this one is correct, while the rest of the four are incorrect. By that means only the third element is infinite while the rest are finite. Similarly, is nan. That means nan is basically not a number. So infinity is not a number. So if there is any infinity, the condition there should be true. So let's check. The third should be true. So you can see third is true while the rest are false. So these are the various conditions or inquiry types that you can have. Now there are some limits, are important limits on these numbers, and you can use these different commands to interpret those limits or use these limits in various functions. For example, d is equal to EPS. EPS is basically the floating point relative accuracy. So let's say d is equal to EPS will give you what is the distance between number 1.0 to the next larger double precision number, that is 2 raised to the power minus 52. Let's run this command. This is 2.2 into 10 to the power minus 16, and as I said, it is the distance between 1.0 to the next double precision number, and you know the next double precision number is 2 raised to the power minus 52. That is the distance. So let's check this value, 2 raised to the power minus 52. So you can see these two are the same numbers. So that d is equal to EPS will give you the distance. Similarly, EPS 1.0, that is same thing. This command means the same, just writing it in a different way. If I run it, you will see the output is same. D is equal to EPS double. It's just double means that by default d is equal to EPS is double, but you can check this thing for single as well. Let's say I run it for double, you can see this is same. But now if I change it to single here, single, so you can see now the number is changed. So now it is the precision but for the single data class. Similarly, Flint max, it will give you the largest consecutive integer in the floating point format, and which is like 2 raised to the power minus 53 in terms of double precision numbers. Here, let's check this one if it is correct or not. So you can see 9.00 10 to the power minus 15, like this is, I have told you, 2 raised to the power 53, and this is the same number. Okay. Similarly, you can check this for the single data type as well. So you just have to specify single data type. Okay, and when you run this, you'll get this number. Now infinity is very important number, and that is used in various programs. If you want to define an infinity as a variable, you can define it like x is equal to infinity, y is equal to infinity, or whatever variable name you want to give, and you will see it is defined. Now in terms of matrices, let's say you want to define a matrix that is 3 by 3 and it's all the elements of this matrix are infinity. You can define it infinity of 3. When you define it 3, that means it's a square matrix that has 3 rows and 3 columns, and it has elements all equal to infinity. Let's check it. You can see infinity. Now if you want to define a matrix, a sparse matrix, or a matrix, not sparse matrix, a matrix that is 2 by 3 by 4, that means 4 2 by 3 matrices then you can, that has all the elements equal to infinity, you can define it like this: 2 class 3 class 4. So that means you are increasing dimension. Let's say 2 class 3 class 4, you'll define it and you will run it. And let me open it up for you guys. So you can see these are 4 matrices, right? And 4 3 by 2 matrix, 2 by 3 matrices. Okay, let's say I want to define instead of 3 dimension, let me define it like 4. Okay, now X is 4D. Now instead of 3 dimension, it has 4 dimensions. You can see it here, 4D, and it has all these matrices defined. If you want to define it like a 5D, you can increase it. Let's say this is now 5D. You can increase the dimensions to as much as you want. You can define it like 60. Now it is 60. You can see it here. Okay. Similarly, you can define, let's say you already have a matrix that has some dimensions and you want to define another matrix that has same dimension but all the elements equal to infinity. You can also do that. Let's say you have already defined matrix like A, and now you can get the size of this A here. Let's say you have size of this A, and you can use this size of A as an input, infinity of size. This is basically a different way of specifying the size of the matrix that has all the elements equal to infinity. Run this and you can see the dimensions are same as an A. Okay, here this is like 3 by 2 and this is also 3 by 2. Now these are all of type double. You can see this is double and this is double. Now if you want to define it as elements that are single, you have to specify that X is equal to infinity of 1 by 2 but single. So let's run it. You can see this is a single row vector. Okay, that is how you will use infinity. Now int max, that will give you the largest value of the specific integer. For example, let me run this: v is equal to int max. Okay, this is the maximum value of the integer in 32-bit. Let's say you want to check it for 64-bit and unassigned integer. Okay, what is the let's say the question is, what is the largest maximum unsigned integer of 64-bit that can be used in MATLAB? So the answer is your line number 219. Let me run it and you can see the value. Okay, similarly you can define other classes here and you will get the output. Similarly for the minimum, it's just a change in the syntax. Instead of int max, you will use int min. Now same goes for nan. As I told you for this infinity, similarly for nans, which is not a number, you can define x as not a number by using nan. Similarly you can define it for the matrices. I'll not repeat that. Just go and replace this nan with infinity in this section here and you will get all the results same. Now next is real maximum number, largest positive floating number that you can have. This was already in the initial section. As I told you, you can get real maximum number, but that will give you the maximum number for the double type. But if you want to get it for single type, you have to specify a single type as well. Similarly for the real min as well, you will use real min instead of real max. So guys, that is all about different data types that you can have and different important functions and that can be used. For the time being, these are just disjoint functions that are not linked to your program, but later on when you learn more in the coming up lectures, when you will see how you can define a function, how you can define certain conditions, at that point of time you'll understand how these different data types will help you in different operations or defining different conditions. And you have checked the different query types as well. So those query types, how those can help in checking different conditions and implementing logics and everything. So this is really important. Try to practice this session 2 to 3 times so that you can understand and remember these different query types and data types. And I'll see you in the next video.